Today we're looking at notes 8-5, dividing polynomials using long division. So in part one of these notes, we're going to be doing a bit of review. So you have done long division before, but just with regular numbers, not polynomials. So if I asked you to divide 746 by 3, 3 is called your divisor, and 746 is called your dividend. Your answer that you get for this problem is called your quotient. So let's start practicing, and I'll remind you how this works. So remember, you only look at the first digit here, the first number, and you ask yourself, how many times does 3 go into 7? Well, 3 goes into 7 twice, and then you say 2 times 3 gives you 6. That's what you put here, and then you subtract. 7 minus 6 is 1, so bring down the 1. Bring down the next number, which is 4. So then you repeat that same process again. How many times does 3 go into 14? 3 goes into 14 4 times, and then you say 4 times 3 gives me 12. So I put that number here, and then again I subtract. 14 minus 12 is 2, and then I drag down my final number. So then you ask yourself, same question, how many times does 3 go into 26? 3 goes into 26 8 times. 8 times 3 is 24, and 26 minus 24 is 2. So we bring that up here, and we put it over the divisor, and we call that our remainder. Okay, so you would this is how you would say it. You'd say 3 goes into 746, 248 times with 2/3 remaining. Okay, so and what I have over here are 3 little dots, and these mean in the mathematical world therefore. Therefore, 3 is not a factor of 746. 3 is not a factor of 746 because there was a remainder. Okay, 3 is not a factor of 746 because there was a remainder. There was something left over. Okay, but likewise, if I ask you to take 744 and divide it by 3, let's see what happens there. So 744 divided by 3. How many times does 3 go into 7? Twice. So 2 times 3 is 6. 7 minus 6 is 1. Drag down this 4. How many times does 3 go into 14? 4 times. 4 times 3 is 12. 14 minus 12 is 2. Then I have 24. How many times does 3 go into 24? Well, 8. 8 times 3 is 24, and 24 minus 24 is 0. Okay, nothing remaining. So therefore, 3 is a factor of 744. And that is because there was no remainder. So better yet, therefore, we can rewrite 3 times 248 equals 744. 3 times 248 equals 744. So this information and this knowledge will come in very handy and useful when we start dividing polynomials. So part 2, the new material. Divide and determine if the given binomial, so remember 2 terms, is a factor of the given polynomial, multiple terms. If it is a factor, then rewrite the polynomial as a product of 2 factors. So like what we did here, rewrite as a product of 2 factors. Okay, so I'm asking you to take 3x to the 4th minus 5x cubed plus 2x squared plus 3x minus 2 and divide it by 3x minus 2. So as you would imagine, there are rules when dividing polynomials. The first and most important rule is the dividend must be in standard form with any missing terms included. So 4, 3, 2, 1, and then number, it is in standard form, no terms are missing. So I went ahead and set up the problem as it should be. Okay, so same process. I really want you to think about the previous process with just the numbers. Okay, just like before, I'm primarily going to be looking at the first term here and the first term here, and I'm going to ask myself, how many times does 3x go into 3x to the 4th? So 3x to the fourth divided by 3x gives me x to the third. You're hopefully right. Okay, and I need to line that up with the x to the third here. So then you go backwards just like we did on the previous and you multiply. X to the third times 3x gives me, hopefully, 3x to the fourth. These should always match. If when you multiply back, these don't match, something's gone wrong here. Okay, so x to the third times 3x is 3x to the fourth, but this is a binomial, so I need to do it to both terms. I need to multiply both terms. X to the third times negative 2 is negative 2x to the third. Another thing I really want you to notice, rules, your terms need to line up with like powers, and they have. Okay, and then just like before, you subtract. 3x to the fourth minus 3x to the fourth, obviously gone, cancels. Negative 5x to the third minus negative 2x cubed. That turns to a plus, so it'd be negative 3x to the third. And then similar to before, but a little bit different, not only drag down the next term, but drag down all the terms. Okay, so dragging down all the terms here, then same question, repeat the process. How many times does 3x go into negative 3x cubed? 3x goes into negative 3x cubed, negative x squared times. Okay, so then repeat the process. Negative x squared times 3x. Negative x squared times 3x is negative 3x cubed. Yay, that's perfect, it matches. Negative x squared times negative 2 is positive 2x squared. Then subtract. Okay, obviously this minus this, it's the same thing, cancels. And then looky here, that's also the same. 2x squared minus 2x squared also cancels. But I do need to drag down what I have remaining, 3x minus 2. Repeat the same process. How many times does 3x go into 3x? Well, it only goes in one time. Notice where I put this 1. It goes above this term here. I have no x term, so I leave a blank. Okay, 1 times 3x is 3x. 1 times negative 2 is negative 2. So when I subtract, 3x minus 3x cancels. Negative 2 minus negative 2 also cancels. My remainder is 0. So that means 3x minus 2 is a factor of this long polynomial. So a couple of things I want you to write. I want you to write the answer. The answer is x cubed minus x squared plus 1. When we divided, that's what we got. And in the directions, I wanted you to tell me, yes, in conclusion, yes, 3x minus 2 is a factor. And then it also wanted me to write the polynomial as a product of the two factors. So I don't have a whole lot of room here, but I'll do the best I can. 3x minus 2 times, 3x minus 2 times x cubed minus x squared plus 1. So this times this equals 3x to the fourth minus 5x cubed plus 2x squared plus 3x minus 2. So of course I would like that to be on a single line, but we didn't have a lot of room here, so that's what we get. Okay, so let's try another example. Okay, example number 2. 3x cubed plus 4x squared plus 10 divided by x minus 2. Okay, notice my setup here. I've put the divisor here, the dividend here, but I took 3x cubed plus 4x squared, put a placeholder for the x term, and then plus 10. Okay, you always need placeholders if there's a missing term. So now, same process. How many times does x go into 3x cubed? X goes into 3x cubed, 3x squared times. Okay, so 3x squared times x is 3x cubed. 3x squared times negative 2 is negative 6x squared. Okay, and then subtract. 3x cubed minus 3x cubed cancels. 4x squared minus negative 6x squared, minus a negative turns positive. So this is going to become 10x squared. Okay, and then drag down my plus 0x plus 10. All right, so now, moving right along, how many times does x go into 10x squared? X goes into 10x squared 10x times. So 10x times x is 10x squared. 10x times negative 2 is negative 20x, and then I subtract. Okay, so 10x squared minus 10x squared cancels. 0x minus negative 20x turns to a positive 20x, drag down the 10. Last step here, how many times does x go into 20x? X goes into 20x 20 times, and then 20 times x is 20x. 20 times negative 2 is negative 40. Okay, then I subtract. 20x minus 20x cancels. 10 minus negative 40 turns to a positive 40, so 50. Notice I don't have anything else. I stopped there. I've got nothing, no more places to go. So my answer for this would be 3x squared plus 10x plus 20. Pay attention to how I write this. It's a positive 50, and I put it over the divisor x minus 2. That's how you would write your final answer when there is a remainder. And also remember I asked in the beginning that important question. Is the divisor a factor of the dividend? No, it's not. X minus 2 is not a factor because there was a remainder. So, nope, it's not a factor. All right, if that was too fast for you and you were too busy copying to pay attention, I would recommend going back through it and watching the video again, because here is your next problem, and I really want you to, once you copy it down, try it on your own. Pause the video, see if you can do it, see if you can get what I get. Okay, so as I go through this, pay attention to the fact that I put, again, a placeholder for the x term that was missing, plus 0x. Okay, and then I'm going to start my process. How many times does x squared go into 3x to the fourth? X squared goes into 3x to the fourth, 3x squared times. 3x squared times x squared is 3x to the fourth. 3x squared times 1 is 3x squared. Pay very close attention to the fact that I skipped this because 3x squared times 1 was 3x squared, and I definitely want my powers to line up on top of each other. So then I subtract, and what happens is these cancel. I need to drag the negative 4x to the third down. 12x squared minus 3x squared is a positive 9x squared. Drag down my plus 0x, drag down my plus 5. And then I need to ask myself, x squared goes into negative 4x cubed how many times? Negative 4x times. Negative 4x times x squared is negative 4x cubed. Negative 4x times 1 is negative 4x. Then I subtract. Okay, those cancel. Drag down my 9x squared. 0x minus negative 4x turns to a positive 4x. Drag this down. Last step here, last placeholder I have. How many times does x squared go into 9x squared? 9 times. 9 times x squared is 9x squared. 9 times 1 is 9. Then I subtract. That cancels. Drag down the 4x. 5 minus 9 is negative 4. I have nowhere else to go. So my final answer is 3x squared minus 4x plus 9 plus 4x minus 4 over x squared plus 1. And therefore, x squared plus 1 is not a factor.